This is the pencast for homework number 3, problem number 32. The problem states 2-point charges 2 centimeters apart have an electric potential energy of negative 100 microjoules. The total charge is 30 nanocoulombs. What are the two charges? So we could draw a picture first. So we know that there are two charges, 2-point charges, right? And we know from the problem it states that they are 2 centimeters apart. So R, which is the distance between the two charges, is 2 centimeters. Right, we don't know whether each charge is positive or negative, we just know that they're 2 centimeters apart. Right, so if we write a list of our unknowns, we know, like I just said, that the distance between the two charges, R, is 2 centimeters, which is equivalent to 0.02 meters. We also know that the potential energy is negative 180 microjoules. So potential energy, which can be represented as U, is equal to negative 180 microjoules, which is equivalent to negative 180 times 10 to the minus 6 joules. It also tells us that the total charge is 30 nanocoulombs. So we know that if we call this Q1 and this Q2, that the total charge Q1 plus Q2 is going to have to equal 30 nanocoulombs, which is equivalent to 30 times 10 to the minus 9 coulombs, right? And so what we're looking for is Q1 and Q2, right? So this is our unknowns, and these are our knowns. So going forward, there's an equation that relates potential energy to charge, and that is U, potential energy, is equal to K times Q1 times Q2 over R. Right? We don't know everything in this equation, but we can come up with an expression, right? So if we plug in everything we know, so we know that potential energy is negative 100 times 10 to the minus 6 joules. K is 9 times 10 to the 9 Newton meters squared over Coulomb squared. We don't know Q1, we don't know Q2, and we know that R is 0.02 meters. If we solve for Q1 times Q2, we could get that Q1 times Q2 is equal to negative 4.0 times 10 to the minus 16 Coulomb squared. These units check out because the units of one charge is coulombs. So if you have a charge times another charge, you should get Coulomb squared. So that checks out. Right, so now what we've created is two equations. Right, we know that previously we came up with this equation, right? We know that Q1 plus Q2 should be equal to 30 times 10 to the minus 9 coulombs, right? So that's an equation we found. Q1 plus Q2 is equal to 30 times 10 to the minus 9 coulombs. We also know that Q1 times Q2, right, is equal to negative 4.0 times 10 to the minus 16 Coulomb squared. So we have two equations, two unknowns, but what we can do is solve for Q2 here. So we get Q2 is equal to 30 times 10 to the minus 9 coulombs minus Q1, right? So now what we know, now we have a relationship with Q2, so we can plug in this expression into equation 2 to get an overall equation that is just in terms of Q1, right? So if we plug in this into here, we would get Q1 times 30 times 10 to the minus 9 coulombs minus Q1 is equal to negative 4.0 times 10 to the minus 16 Coulomb squared. Right? So now what we can do is distribute that Q1. So we're going to get negative Q1 squared plus 30 times 10 to the minus 9 coulombs times Q1 is equal to negative 4.0 times 10 to the minus 16 coulombs squared. Okay, now what I'm going to do is get everything onto one side, right? So I'm going to move Q1 squared and this other term to the other side. So we're going to get Q1 squared minus 30 times 10 to the minus 9 coulombs times Q1 is equal to minus 4.0 times 10 to the minus 16 coulombs squared is equal to 0. Right? So what we are left with now is a quadratic equation. To solve a quadratic equation, you could use the quadratic formula. So use quadratic formula, which is probably the best idea in this case because you're dealing with some pretty large numbers, or you could try and factor it if you would like, if it is factorable, right? So I use a quadratic formula and I came up with that Q1 is equal to 40 nanocoulombs, so positive 40 nanocoulombs, and it's equal to negative 10 nanocoulombs. Cool. Right. So that, I probably should have said that. So that is equal to 4 times 10 to the 8 coulombs, and this is equal to negative 1.0 times 10 to the minus 8 coulombs. Right, I just converted to nanocoulombs right away. But this is what you would get when you actually did the quadratic formula, right? So this is what I have so far, right? So Q1 can be either 40 nanocoulombs or it could be negative 10 nanocoulombs. So now what we want to do is figure out Q2, right? So if we know that Q1 is equal to plus positive 40 nanocoulombs, that would mean that Q2, right, if we have this relationship, we can figure out Q2 now that we know Q1. So Q2 is going to be 30 nanocoulombs minus Q1, right? So Q2 is going to be 30 nanocoulombs minus, we figured if Q1 is equal to 40 nanocoulombs, so it's going to be 30 minus 40 nanocoulombs, so that's Q2 is going to be negative 10 nanocoulombs, right? So if Q1 was equal to 40 nanocoulombs, then Q2 would have to be negative 10 nanocoulombs, right? But also Q1 could be negative 10 nanocoulombs, right? And if that were the case, we're going to do the same thing, right? If that were the case, that means that Q2 would have to be 30 nanocoulombs minus, Q1 minus negative 10 nanocoulombs. So negative times a negative is going to be a positive, so it's going to be 30 nanocoulombs plus 10 nanocoulombs. So we would get 2Q is equal to 40 nanocoulombs positive, right? So those are the two cases, right? We don't really know whether or not Q1 is 40 nanocoulombs or negative 10 nanocoulombs. The only thing that we really do know that the two charges, so the two unknown charges are either positive 40 nanocoulombs or negative 10 nanocoulombs, right? This could be Q1, this could be 2Q as you see here, right? Q1 could be 40 nanocoulombs, which would make Q2 negative 10 nanocoulombs, or Q1 could be negative 10 nanocoulombs, which would make Q2 positive 40 nanocoulombs, right? But this would be our answer.